thing we talk about is power functions. So what are power functions? It got from fx equals to x to the power of r, where r is a non-zero real number. Okay, it's a non-zero real number. That's called a power function. Well, the r can be rational, can be irrational, can be positive, can be negative. Basically x to the power of anything. Okay, x to the power of anything is not excluding 0. They are called power functions. If it equals to 0, it will be 1. So it's a horizontal line. It's not a power function. We will investigate this more in year 12 about like the fraction one. But today we're going to talk about two types. One is when n is an odd number, and the other one is when n is an even number. So we only talk about the integer, okay, positive integer graph. When it is a fraction, for example, x to the power 4/3, it will look different compared to what we investigate today. But today we think about the special one. So x to the power of n is an odd number. So we won't really investigate 1. So because x to the power of 1 is a linear, it's not really something very exciting. So we start to talk about it from x to the power of 3, x to the power of 5, and x to the power of 7. Let's have a think about what those graphs look like. And if we sketch that on the same set of x's, what the graph will look like. Okay, so let's just sketch that. Okay, if I have x and y, well, everyone knows what x cubed looks like, right? What x cubed looks like. So let's just sketch x cubed first. Well, I'll use a blue color to sketch x cubed. So don't worry about the scaling, because when you sketch x to the power of 5 and x to the power of 7, the scaling will automatically show, like, I want to compare between the three graphs, like which one is higher, which one is lower, any intersections, or they always above or always below. Now let's think about x to the power of 5. Well, this is x to the power of 3. Let's think about x to the power of 5. Are there any intersections? X to the power of 3 and x to the power of 5. Origin? Anything else? Well, if we solve for it, x to the power of 3 equals to x to the power of 5. Can you solve that for me? By factorize. By factorize. You can factorize it. Don't shake your head. You can do it. Right? We can do it. Well, that's polynomial, like very easy polynomial solving. So what I can do next? X cubed as common factor and minus 1. What else? X cubed. Yeah, so what's the intersection? You have plus 1 and negative 1. Right? We have, I think it should be approximately symmetrical. Let's say it's here. You see, like 1 and 0 is always the special number. 1 to the power of anything will still be 1. Well, negative 1 to the power of odd number will be negative 1. Even number will be 1. So like 1 is the special point. They will intersect. They only intersect at those 3 points, right? Only intersects at those 3 points. Do you remember what I have talked about yesterday about x squared and x to the power of 4? Like they intersect at 3 points as well. If we go up a little bit. Here, see, if you intersect at 0 and then 1, you need to above first and then below, or below first and then above, right? That's how the graph should look like. See, like I can't make the red one always above the blue one, or I can't make the blue one always above the red one, because they intersect. Like you need to twist it, like intersect here and then go to intersect there another time. So it must like go above first and then below, or below first and then above. So there must be an intersection like that. So same as this one. Okay, again, like yesterday, I think about the value 2. Well, 2 to the power of 3 and 2 to the power of 5, which one is larger? 5, right? So the red graph should above the blue graph after 1, because at the point 2 is larger. Again, think about a half. A half to the power of 3 and a half to the power of 5, which one is larger? 3, right? Is 1 on 8 or 1 on like, what's that? 32? 1 on 32 and 1 on 8. 1 on 8 is larger. So the blue graph is actually larger, like higher than the red graph in between 0 and 1, because the value you take is half, right? In between 0 and 1. So the graph should look like this. If you make it larger, you can see it's not that obvious, but it twisted like below first and then above. So on this side, it will be the same. See, it will be the same. Because it's symmetrical also. The sketch is not very good, but that's how it should look like. Just let you know, x to the power of 3, 7, 5, 9, they all look like a cubic shape. Okay, they all look like a cubic shape. X to the power of any odd number is the same shape as the cubic. So, but like they will intersect, the dilation is a little bit different. And then let's think about x to the, well, I'll use another color. Let's use a purple color. X to the power of 7 and x to the power of 5 and x to the power of 3. Is there any intersections? Where's the intersection? 0, 0, 1, 1, negative 1, negative 1. So they still intersect at those 3 points. Well, same reason, like x to the power of 5 and x to the power of 7. 7 is like 2 to the power of 7 is larger. So after 1, it should be above. And then in between 0 and 1, therefore, should be below. So, too hard to sketch, but this is like this. See, like should be below the red one and then above the red one. And then if you have x to the power of 9, 11, they all looks the same way. Okay, they all looks the same way. But remember, there's 3 intersections. Okay, there's 3 intersections on those graphs. That's how the x to the power of n, when n is an odd number, that's how the graph looks like. And let's have a look. Okay, properties. Well, f0 equals to 0. As x approaching to infinity, y all approaching to infinity. As x approaching to negative infinity, y all approaching to negative infinity. If there are positive odd numbers, when the power is larger, okay, when the power is larger, so x to the power of m, x to the power of n, when the power is larger, well, you can see the graph. The graph will be larger. You can see from the graph, okay, the higher the power, well, after one is getting above, like it's getting larger, but in between 0 and 1 is smaller, okay, smaller. So that's what it's talking about. So because it's a half to a higher power, it will make a smaller number. So 1 over something will give you a smaller number. That's what here talking about. And when they are equal is at 3 points, 0, 1, and negative 1. Okay, 1, 0, and negative 1. So that's the even function, odd function. Okay, x to the power of n when n is odd. And let's have a look at the even one. Well, even one, we have seen. Draw it below because it's not going to go below the axis. So if we sketch That's x to the power of 2. So 1, 1, negative 1, 1 will be the intersection because this positive is even number. That's what we talked about yesterday. Okay, that's x to the power of 4. It should be above after 1. Again, same reason. It should be above x to the power of 2 after 1. That's 1, 1, and that's negative 1, 1. And then, well, we can imagine what x to the power of 6 should look like. X to the power of 6 will be above after that. Get even flat. Well, my graph is really ugly, but can't really, well, on the calculator you almost can't see like which one is above, which one is below. It's very, very close to each other. I want to make you see clearly like what's the graph, like the higher or lower, so I make it really flat. It shouldn't be that flat and it should be smooth graph. But anyway, x to the power of 6 will be below the x to the power of 4, in between negative 1 and 1, and also intersects at 0, 0, and then are above the red one after negative 1 and 1. All right. Okay, going to talk about the definition. Okay, definition. This definition, I was thinking about not that important before, but actually last year VC exam there's one multiple choice question is talking about even function and odd function, and most students can't get it. What is an even function? Even function is, well, if you think about the graph, it must be symmetrical about the y-axis. That's an even function. Like x to the power of 2, x to the power of 4, they are all even functions when they're symmetrical about the y-axis. Okay, that's the only requirement. So symmetrical about the y-axis. But if you can't see the graph, if you don't have the graph, what you can do? You can use this equation to test it. So when you sub a negative value, that will be the same as when you sub the positive of that value. So f2 equals to f negative 2, f3 equals to f negative 3. That's like for all the points, okay, for all the points, not only 1 point. So that's an even function. So what's an odd function? Odd function is symmetrical about the origin. Okay, symmetrical about the origin. That's the origin. Well, those graphs are called symmetrical about the origin. You can rotate that about origin and to get this half. Okay, get this half rotated. The formula we tested is f negative x equals to negative fx. F negative x equals to negative fx. What that means? So f2 equals to negative f negative 2. Well, or I can say negative f2 equals to f negative 2. So the negative value equals to the negative of the positive value. Sometimes they want, well, like last year exam, no one tells you they are even function or odd function. The only thing they give, and you don't know what's the equation, okay, you don't know what's the equation. The only thing they give you is, they tell you f negative x equals fx. Then you need to know that's an even function. And then for an even function, you know what? It's symmetrical about the y-axis. Okay, that's the thing you can see from this formula. Is they can tell you directly it's an even function, or they can tell you this formula, you know it's an even function. And you know it's an even function, what else you know? You know it's symmetrical about the y-axis. So that's the thing you need to think about. Then how we can test whether it is an even function, odd function, or neither. Okay, state whether each of the following polynomials is even or odd. Well, we can sketch for it. Okay, we can sketch for it, but like it's too slow to sketch it, and then sometimes maybe not that accurate. So what we'll do is, what we want to see is f negative x. Okay, that's what we want to see. We want to see f negative x. Can you see all the two formulas is relate to fx and f negative x, that relate to two things, okay? So we want to see what's the relationship between f negative x and fx. Are they the same or are they opposite, like the negative of the other? Then we can decide it's positive or negative, odd or even. So f negative x is 6 negative x to the power of 4 minus 3 negative x to the power of 2. Well, that's like substitution. How substitute 2, substitute 4? We substitute negative x. And that equals to 6x to the power of 4 minus 3x to the power of 2. Because it's squared and quarter and they get cancelled, it's still the same. And can you see f negative x equals to fx? Because what you get here is same as fx. Okay, it's same as fx. So the statement we can see here is f negative x equals to fx, and therefore is an even function. Okay, therefore is an even function because it satisfies the formula. Okay, satisfy the formula. But what you can't do, okay, what you can't do, I think some of you might do this because I see this every year. You can see, okay, a lot of you, I think you can see, oh, that should be an even function because I got all the even powers. A lot of students will start their writing like this. They start the discussion with this line, and then they put negative, they put left hand side as this, and then right hand side repeat it again, 4 minus 3x squared, and then simplify the side, and then say, oh, they are the same, and so therefore it's an even function. That's a wrong discussion. Okay, that's a wrong showing question. Like, you can't show things in this way. Why? Like, a simple reason why you know f negative x equals fx at the beginning. Well, if you already know that, if you treat this as something you already know what we need to prove, we already know that's an even function. What's all this calculation talking about? Like, no point.
Right.
There's no if, like, you don't know anything. What you want to, what I want to, well, if you say if, okay, if this, then it's an even function. Yeah, then it's an even function. But you make an assumption here. You make an assumption here. This equal is not a real equal. Let's say, how about if you think something wrong, it's not an even function, and you find your left hand side is not equal to right hand side. What you can do at that time? Like, what's your discussion at that time? Like, say if there's a power of 3, and you think wrong, like you think it's an even function, you make the assumption if there, and then you work out, oh, but that's a negative, and they are not equal. Then where's the discussion should go? Like, you already say they are equal at the beginning, but it's not equal in the end, and then you will change everything back to like not equal. But I can't say anything now, like where my discussion should go, like it stopped. Okay, so it's wrong assumption. Like, I can't assume anything because there's not enough information for me to see they are equal or they don't equal. We can't start. Well, can you see this is actually my conclusion? This is my conclusion. You can't write your conclusion at the beginning, right? You can't make your conclusion at the beginning. You need to put the evidence first, and then that's your conclusion. You can't say, oh, I think they are equal. Then you already think they are equal. Why we calculate it? You just say it's an even function. That's it. Okay? So it's kind of tricky. Like, I can see this is a big problem. Okay? This is a really serious problem if you write things in this way. But you may think, oh, we get the same result. Like, what's the difference? That's like, what should go first and what should be your conclusion? That's the problem. Okay? It's follow the logic. Yeah. Which one? Left hand side?
Yeah.
But yeah, but what I do is I have shown y negative x equals to fx. Like I have calculated f negative x first, right?
Okay, so as long as we put the f negative x equals fx at the end of the
Yeah, like should be the end, not at the beginning, because I have shown why they are equal. I have seen really explicitly why they are equal.
But then what happens if then if they don't end up being equal?
Then you say they are not even function.
And then we have to go through and make it.
No, can you see my f negative x is exactly equals to that. It's not going to change. It is that. It's never not going to be that. It's just like, and then my f negative x is still that, and then I compare that with the fx. It's a comparison step, and then I only need to say this is equal or they not equal, and then I make the conclusion. It's different. Okay. Yeah.
If someone asks you to prove if it's odd, can you use the even rule instead of not even?
Wait, sorry. You want to?
So if someone says that prove that this is odd.
This is odd.
Yeah, and you use the
No. You can't say even or. That's two types, and you have a lot of function which is neither.
Oh.
It can't be only if or even. Not all the graph looks in that way, right? Okay. Again, I guess that should be like even odd function, right? Because all the powers like odd numbers, but I can't say anything yet. So I will still see what my g negative x equals to. Okay, my g negative x equals to. That's 3 negative x to the power 5 minus negative x to the power of 3 and plus negative x. That's negative 3x to the power of 5. My g negative x equals to that plus x to the power of 3 minus x. And one more step I can do is, well, I want to make it explicitly connect to the gx. So I take a negative sign. Yeah, I take negative sign as vector. So I can see g negative x equals to negative gx. So this is an odd function. It's symmetrical about the origin. Okay, symmetrical about the origin. I want to add something on the previous page. Odd function, like see odd function must pass origin. But even function not necessary. Okay, even function not necessary because you can still be symmetrical about the y-axis when it's not passing through the origin. For example, like this. Okay, still symmetrical about the y-axis, but it's not going to pass through the origin. But for odd function, is symmetrical about the origin. So origin must be the middle point. You need to pass through the origin, then to make it an odd function. So odd function must pass through the origin, but even function not necessary. It can, cannot. So 3, we can see h to the power of negative x equals to negative x to the power of 6 minus 3 negative x to the power of 2 plus 2. So h negative x equals to x to the power of 6 minus 3x squared plus 2. And we can see it's exactly the same as hx. So that's even function. It is symmetrical about the y-axis. Okay, last one. Well, last one, I want to see m negative x. That equals to negative x squared plus negative x. And that is x squared minus x. Okay, obviously is not equals to mx, right? It's not equals to mx, it's different. And also is not equals to negative mx. Well, it's not the negative of that. Because we can see negative mx equals to negative x squared minus x. But it's positive x squared minus x. So it's not negative mx as well. So, no, it's not equal. So neither, okay. It's not even function or odd function. It's not even function or odd function. So it's not symmetrical about the y-axis. It's not symmetrical about the origin. Okay, this question here, well, I think you can test about whether they're either or odd. But what I want you to do is to show you how to prove something. Okay, how to show something. This is should be the correct step to show something. So just pay attention to that. It's not hard. Okay, even function, odd function itself, the definition itself is not hard. It is hard when it combined with other questions. Okay, when it combined with other questions, it becomes harder. So you just need to remember the property for even function, odd function. For even function, is symmetrical about the y-axis. All the x-intercept needs to be symmetrical about each other. If you have x-intercept at 2, then you must have another one at negative 2. You have 3, you have negative 3. Okay, and for odd function is like rotate about the origin, so it's symmetrical about the origin. That's what all you need to remember. Okay, example 6. Example 6. This question is quite good because it shows you how to sketch some repeated factors with 3 times repeated factors. So let's have a look at this graph. Fx less than or equals to gx. So what I will do is fx less than or equals to gx. That's what we have. X to the power 4 less than or equals to 2x cubed. How we should solve for it? What do you do first? Bring to one side because I need one side to be 0 and then see the graph. Okay, whether it's above x-axis or below x-axis. So x to the power 4 minus 2x cubed less than or equals to 0. What next? Factorize what I can factorize. Yeah. And x minus 2 less than or equals to 0. And what I should do? Sorry. Oh, no x squared. It's only x minus 2, I think. Why? It's already linear. We'll stop when we get linear. What's the next step? Like, it's all good here. Sketch the graph. Okay, sketch. Solve inequality, you must sketch for graphs. Okay, you must sketch for graphs. You need to see the graph. Okay, where's my x-intercept? 0, 0 and 2, 0. Where I should start my graph? Left, right, top, bottom. Where I should start it? Top right. Okay, top right. Positive x leading term positive. Top right. So if it's top right. Okay. Where's my repeated factor? My repeated factor is at 0, 0, right? It repeats odd number of times. Odd number of times. What it becomes? Stationary point of inflection. Okay, stationary point of inflection. So I start from top right. The graph looks like this. And that becomes a stationary point of inflection. Yeah, that's how the shape looks like. I want less than or equals to 0. So this part to this part, less than or equals to 0. It's that bit. So, well, the x is here. So x belongs to 0 to 2 inclusive. Zero to 2 inclusive. Any questions? Okay, this question is basically show you how to sketch the repeat factor for odd number of times, so that becomes a stationary point of inflection. You need to show that, okay, on the graph if asked you to sketch for it. Okay. I want to show you example 2 first, okay? For some calculator thing. Okay. Example 2. Let's do example 2 first. It is found that 250 meters of the path of a stream can be modeled by a cubic function. So that's a cubic function. The cubic path through the points 0, 0, and that give you 4 points, right? Give you 4 points, and it tells you that's a cubic function. What kind of equation we can write at the beginning? Yeah, y equals to, well, let's say fx. So fx equals to, what's a cubic? How to represent a cubic function? A. Okay, can you see the shape? The shape is not the stationary point of inflection form. It's not that shape. So you won't have that formula. Okay, you won't have that formula. What you will have, there's no x-intercept. I can't see x-intercept from my the point given to me. So there's no point to write into the factorized form. So I'll just give a general form to that. ax cubed plus bx squared plus cx. Do I need plus d? Why I don't need plus d? Yeah, because it passed through 0, 0, so we have d value equals to 0. And then what I can do is substitute all of this point in and then solve for it, right? And solve for ABC. But it's, you know, like it's too hard to do it by hand. So I'll show you how to do it by calculator. Well, I know you know how to substitute. For example, 22 equals to 100 cube A plus 100 square B plus 100 C. But it's still too long to type, okay? Still too long to type in. Well, think about it, have another 2 equations and type into the calculator, and the button is very small. So it's hard to do that. So instead of that, what I will introduce here is, do you remember the define function I told you? Do you remember the define the function, how to, okay, so what this function called is a times, okay, remember the times, x cubed plus b, you must put the times. If you don't put the times, you're not going to have any value out. bx squared plus c times x. Okay, that's the equation for the formula. You must put the times. Well, for example, 2y, you can put 2y, don't need the times. 2x is okay, 2z is okay. But 2a, you must put 2 times a. Okay, 2 times a. It's only x, y, z can be work with numbers directly, combined directly, but all the other letters is not, you can't ignore the times. You must put the times there. So you must put A times that, B times that, C times that. And then we define this function. The name of this function is called fx. So control VAR, control is this blue button here, and VAR is the button above 9. You have the arrow out. Okay, you have the arrow. Control VAR, give that arrow, and then you put the name, like what you want to name the function as. You name as f. And then what's the variable? The bracket is the variable. So you can put ABC in. If you put ABC, A become your variable, and then X, B, C, O becomes the constant. So X is my variable here. Okay, so and press enter. Done. Like it defined it for you. Alright. Then I want to solve simultaneous equations. Okay, I want to solve simultaneous equations. Menu 3-1 to solve Menu 3-1. Okay, solve for the function. I have 3 simultaneous equations. I press the button on the right hand side of 9 and I got this simultaneous equation sign. I want 3 of that because I want to solve 3 equations. Okay, what do I have? I have 122. Y value equals to 22 and X value equals to 100. What all I need to do is just press F 100 equals to 22. F 100 equals to 22. Because I already defined my function is that when I put F 100, the calculator will substitute that for me. I don't need to type 100 cubed times A, 100 squared times B, 100 times C. So the calculator will do that. And the next one is negative 10, 150. So negative 10 equals to F 150. And negative 20 to 100. That's the same as you put Y and X in, but the calculator will do it for you. And what I want to solve is comma A, comma B, comma C. That's the 3 coefficient I want to solve. And it will give it to you. Okay, comma A, comma B, and comma C. That will give to you. So this is avoid us to type a long equation for 3 times. Okay, so F something will directly work for you. Yeah, you don't need to put the curly bracket. Just type comma A, comma B, comma C. That will work. This is like a quick way because year 12 did a test last week, and then the last question is ask them, give them 4 points, and ask them to find the like the quartic. Give them 5 points and ask for the quartic. And if they type that 5 equations in, it's really long. So if they can do that, it's really quick to find it. Yes.
So I have to go this test.
No. It's a factorized like topic. You can't get test. You can factorize by calculator. Okay, like, well, copy the value down. Like that's the answer for the cubic. Okay, that's the answer for the cubic. Well, no way we can do it by hand. Okay, no way we can do. Well, we can, but like too long, like too large numbers here. So that's the cubic. X cubed plus okay, that's the equation. And the question asks us, the next question asks us, find the maximum deviation of the graph from the x-axis between 0 to 250. Okay, what's the deviation? It's either here or here. Okay, it's either here or here. So it's like how much is going to go up from the x-axis, how much can go down from the axis. So it's the deviation like those two parts. What I need to do is I need to find the turning point, right? I need to find the turning point. Well, how we can find turning point? You don't know how to do it algebraically yet, but we can use the calculator to do it. So back to the calculator. Okay, your A value is that. Okay, your A value is that. Okay. You can copy that down. A times x cubed plus. You can hold the shift button and right to copy it. Remember that? Shift and right to copy. My one's a little bit different. I can't do by that way, but your calculator can. Shift and left or right to highlight. Left or right. Buttons. Okay, that's the equation, and we can redefine it. So control VAR, that's fx. Like I still call that fx. So redefine it because before ABC is undefined, like it's no numbers. But now I know what's the number. Now we back to the graphing page. We want to sketch fx, but we only want to sketch control equal to define it. Okay, give the bar to define x in between 0 to 250, because what all I want to see is x in between 0 to 250. Well, if you forget what to do, you can back to this video and then you can see what I actually click on that part. So you can see what I'm doing. 250, and well, I can't see the full graph because it's only 10 on the right hand side. So I need to change the full window setting and 1. Well, x start from 0 up to 250. Well, I don't know what I should have, but let's make a negative 20 and the 40 here maybe. Well, see, I'm still a little bit below there. I can go again for 1. Well, that's basically, it's a guess. Negative 30 should work. Well, I can see the full graph now. And go for menu, analyze the graph, and I want minimum first. Okay, I want that point first. Move to the left, move to the right, give me the turning point. And then I can go menu 6 and maximum 3. Left, right, give me the maximum point. See, the maximum point is with y value of 38.20 and the negative one gives me 21.64. So the greatest deviation should be 38.2. Yep. You just directly go to the graphing page. Home graphing, do you know how to get graph? Home page? No, just, do you use the scratch pad? Is that the scratch? Don't use scratch pad. You can't use scratch pad. Okay, don't use scratch pad, you only use those 2 buttons here. Only those 2. Because when you define things in that one, you can directly sketch in that one, but scratch pad I think it won't work. Sorry? You don't use it. Well, like my thing should save it because when I open up again, like it's not stored there. But your calculator got the memory, so you don't need to, unless you clear it. You can go back to the current page by click here, the full current. You're back to this page, but don't use the scratch pad. Okay, don't use the scratch pad. Only use the bottom 2, like the graphing and the calculator one. So the greatest deviation will be 38.2. Okay, 38.21. Because the other one got a negative 21. Like it's not a negative problem, it's the not big enough, like it's 21 only, and the other one is 38. So we take the greatest deviation as 38.2. All right, quickly, I want to finish that one. A square sheet of a team measure as 12 times 12.
If it was negative, but negative 39. then
Use
you do-
39.
Okay.
You go for 39. Like the division is only how much you get below or above. Okay, so you have a square thing here and four side cut it. Well, against the box question, you can make the box. Well, the volume, if I go like this, fold it, and the volume of x should equals to 12 minus 2x times 12 minus 2x times by x, right? Because the length, width is the same and the height is x. That's how you find the volume of this box. And A is find the value of x when it gives you a volume of 100. So you solve that equals to 100. I'll show you everything on calculator now. Well, I save it, Control VAR as Vx again, and menu 3 to solve. I want to solve Vx equals to 100, comma x. Well, it will give you x equals to 1 or those two values, but I will go for Control Enter to see what actually the values are. So it can be 1 or 3.2, 7. It can't be 7.79. Can you think about that? You can't cut more than 6. You can't cut more than 6. If you cut more than 6, it will be nothing left. So you can only cut up to 6. So that will be rejected. So what you have is 1 and the other one 3.2, that one. So and then, well, finish up this last bit. If you sketch a graph Vx, and then you restrict it. Okay, if you restrict it in between 0 to 6. Well, I can't cut more than 6 and less than 0, so it's in between that. Just drag it a little bit. And then 4-1. Okay, I will just change it to a 50. Still too small. It's times 200. Oh, no. Let's go for 200. Okay, that's the shape of the graph. That's the maximum volume. Okay, that's the maximum volume. So go 6 and max. We can go left and right to get the maximum. The maximum is 1 to 8. Well, it's the integer number here. That's the volume, what the volume should look like, and the maximum gives you 2 and 1 to 8. Okay, so those two questions all be done by calculator. All right, end of chapter 6.